This is 2014 MEXT Undergraduate Mathematics A paper. Section 1, Number 1. Root 7 is between root 4 and root 9, which are 2 and 3 respectively. So root 7 must be 2 point something. So the integer part, a, is 2, and the decimal part is b. Therefore, root 7 can be expressed as a plus b or 2 plus b. b is root 7 minus 2. So the fraction a over b becomes 2 over root 7 minus 2. Multiply both the denominator and the numerator by root 7 plus 2. Now, root 7 is closer to root 9 than it is to root 4. So we can expect root 7 to be between 2.5 and 3. So let's assume root 7 is 2.6. 2 times 2.6 plus 4 over 3 is 3 point something. So the integer part is 3. And next, let's assume root 7 is 2.9. 2 times 2.9 plus 4 over 3 is, once again, 3 point something. The integer part must be 3. So the answer is 3. Section 1, Number 2. In this question, we have a cone with a diameter of 12 and a height of 8. And we have a sphere inside the cone, and the goal in this question is to find the volume of the sphere. And in order to calculate the volume of a sphere, we need to find the radius of the sphere. So let's assume that point D is the origin of a two-dimensional coordinate system, which means that the coordinates of A become minus 6, 0, and B is 6, 0, and C becomes 0, 8. Let's try to find the equation of line AC, 8 minus 0, and the y-intercept is 8. So the equation of AC is y equals 4 over 3x plus 8. Next, because AC is a tangent to the circle, AC and XO must be perpendicular to each other, which means that the slope of XO is minus 3 over 4. The y-intercept of XO is r. Therefore, the equation of XO is y equals minus 3 over 4x plus r. Now let's pay attention to ADOX. The angle here and the angle here are both 90 degrees. OD and OX are both R. Therefore, AOX and AOD are congruent triangles. Since AD is 6, AX must also be 6. Using the triangle ADC, let's calculate the length of AC. AD is 6 and DC is 8. Therefore, AC is root 6 squared plus 8 squared. Therefore, AC is 10. Now, let's draw a perpendicular line from X to AB, and let the intersection be called Y. Next, let's pay attention to AYX and ADC. These two triangles are similar. In other words, the ratio AX to AC is equal to the ratio AY to AD. AX is 6, AC is 10, AY 6. So the length of AY is 18 over 5. So what is the distance between Y and D here? It must be AD minus AY, or 6 minus 18 over 5, which is 12 over 5. Therefore, the point y has the coordinates minus 12 over 5, 0, which means that the x-coordinate of the point x is also minus 12 over 5. Now we can substitute this x value into the equation of AC to find the corresponding y value. So the y-coordinate of point x is 24 over 5. And plugging these values into the equation of OX, we can finally find the value of radius r. So the radius is 3. Section 1, number 3. In this question, we need to find how many digits this number has, using this approximation. So first of all, log base a of b equals c can be rewritten as a raised to the power of c is b. Therefore, log base 10 of 2 equals 0.3010 can be expressed as 10 to the power of 0.3010 equals 2. Next, 5 is 10 over 2. So 5 to the power of 29 is 10 over 2 to the power of 29. And here we can replace 2 with 10 to the power of 0.3010. Next, recall that x to the power of a over x to the power of b is x to the power of a minus b. Therefore, this is equal to 10 raised to the power of 1 minus 0.3010, which is 0.699. Next, a raised to the power of b raised to the power of c is a raised to the power of b times c. So this is 10 raised to the power of 0.699 times 29, which is 10 raised to the power of 20.271. Because 10 to the power of n has n plus 1 digits, this number has 21 digits. And this is the answer. Section 1, number 4. In this question, we have a circle with a radius of 2, and we need to find the minimum distance between a point on this circle and a point on this line. What we are going to do first is to draw a parallel line that is tangent to the circle, like this. And we need to find the point of tangency here, and then we need to find the minimum distance between this point of tangency and the original straight line. So, to find the slope of this original straight line, let's rewrite this equation. Since the red line is parallel to the black line, the slope must also be minus 3 over 4. Next, the equation of the circle is x squared plus y squared equals r squared. In this case, r is 2, so we have 4. Let's solve this equation with respect to y. Since we are dealing with the upper half of the circle, we're going to take the positive version. Because we are dealing with tangents, we need to be able to differentiate y with respect to x. Let's rewrite this. And dy dx is, bring the exponent to the front, 1/2 times 4 minus x squared. 1/2 minus 1 is minus 1/2, and times, we need to differentiate the inside of the brackets. The derivative of 4 minus x squared is minus 2x, so we need to multiply by minus 2x at the end. So, this is equal to minus x over root 4 minus x squared. Now, because the slope of this red tangent is minus 3 over 4, let this be equal to minus 3 over 4. And let's square both sides. So x is plus or minus 6 over 5. But because we're dealing with the first quadrant, we need the positive version. So now we know the x-coordinate of the point of tangency here. So let's substitute this value into the equation of the semicircle to find the corresponding y value. So the coordinates of this point of tangency here, 6 over 5, 8 over 5. To find the shortest distance between this point and the black line, we need to find the equation of the normal that goes through the point of tangency. The slope of the normal must be 4 over 3. What is the equation of the line that goes through this point with a slope of 4 over 3? The normal happens to go through the origin, so the equation of the normal is y equals 4 over 3x. So let's find the intersection between the original black line and the normal. So the x-coordinate of the intersection is 36 over 25. And let's substitute this value into the equation of the normal to find its corresponding y value. So the y value is 48 over 25. So now we can finally find the distance between these 2 points. So the minimum distance between a point on the circle and a point on this black line is 2 over 5. Section 1, number 5. In this question, we are given the first 2 terms of a sequence, and we are also given this equation. A function that is derived inductively like this is called a recurrence relation, and a recurrence relation that has k-1 or k+1 is called the first order recurrence relation, and ones that have k-2 or k+2 are called second order recurrence relations. So this equation has k-1, and k-2. So this is a second order recurrence relation. And in general, when we have a second order recurrence relation like this, we can obtain what's called a characteristic relation in the following form. So in this question, the value of A is 4 and the value of B is -3. So the characteristic relation of this second order recurrence relation is x squared minus 4x plus 3. And we need to find the roots to this quadratic equation. So x is 1 or 3. If the characteristic relation has 2 distinct roots, the following can be said. X sub n equals c sub 1 times r sub 1 to the power of n plus c sub 2 times r sub 2 to the power of n. C sub 1 and C sub 2 are constants. R sub 1 and R sub 2 are the roots. So in this case, A sub k is C sub 1 times 1 raised to the power of k plus C sub 2 times 3 raised to the power of k, which is C sub 1 plus C sub 2 times 3 raised to the power of k. Next, we need to find the values of the constants c sub 1 and c sub 2. So let's consider the case where k is 1. A sub 1 is c sub 1 plus c sub 2 times 3 raised to the power of 1. And we were given in the question that a sub 1 is 1. Next, when k is 2, a sub 2 is c sub 1 plus c sub 2 times 2 squared. A sub 2 is 2, c sub 1, 9 times c sub 2. So now we can solve these two equations simultaneously to find the values of c sub 1 and c sub 2. So now we know that c sub 2 is 1 over 6, and let's substitute this value of c sub 2 into the first equation. So c sub 1 is 1/2. So therefore, a sub k is 1 over 2 plus 1 over 6 times 3 raised to the power of k. Now, the question wants us to find a sub k in this form. So let's try to conform the right-hand side of this equation to this form. First of all, 6 can be written as 2 times 3. 3 raised to the power of k divided by 3 is 3 raised to the power of k minus 1. Therefore, a sub k is 1 plus 3 raised to the power of k minus 1 over 2. And this is the final answer. Section 1, number 6. In this question, we are given a function, f of x, and we are told that f of x is a linear function, and we are also told that this definite integral evaluates to m times m plus 1 over 2, and we need to find the original function, f of x, expressed in this form. So first of all, since we are dealing with an integral, let's integrate f of x. The antiderivative of f of x is ax squared over 2 plus bx. So let's substitute m and minus m over 2 into the antiderivative of f. Now, from this equation, we know that this is equal to m times m plus 1 over 2. This part corresponds to this part. This part corresponds to this part. Therefore, 3a over 8 is 1/2. So a is 4 over 3. Likewise, 3b over 2 is 1/2. So b is 1/3. Therefore, f of x is 4 over 3x plus 1 over 3. So the answer is 4x plus 1 over 3. Section 2. In this question, we have a semicircle, and the diameter AB is 4, and point C is somewhere on the arc. We need to find the area of triangle ABC when the area is maximum. So when the area of ABC is maximum, point C should be directly above the center of the circle. So point C should be placed here. And because the radius is 2, the height of the triangle is 2. Therefore, the area is 1/2 times 4 times 2. So the answer to the first question is 4. In the second question, the area of the triangle ABC is 1/2 of the maximum area, which means that the area should be 2, and point C is nearer to point A than to point B. And we need to find the angle CAB. So C should be closer to A than to B, so it's somewhere here, and we need to find the angle CAB. First of all, the area of CAB needs to be 2. Because the base of the triangle is constant, the height here must be 1. The line from the center of the circle to point C must have the length of 2 because OC is the radius. So we can calculate the distance here. And let's call this point D. CD is 1 and CO is 2. So we can use the Pythagorean theorem to calculate the distance DO. So the distance DO is √3. Recall that tangent 60 degrees is √3 over 1. So this angle here must be 60 degrees. And this angle here is 30 degrees. That means the external angle here is 150 degrees. So this is 15 degrees, and this is also 15 degrees. AOC and COB are similar triangles, so this angle here is 15 degrees, and the green angle here must be 60 plus 15, or 75 degrees. So the answer is, the angle CAB is 75 degrees. Section 3. In this question, we have an equation that looks like this, and we need to express this equation in terms of t, where t is x plus 1 over x. Let's square both sides of this equation. So t squared is x plus 1 over x squared, which is x squared plus 2 plus 1 over x squared. Therefore, t squared minus 2 is x squared plus 1 over x squared. Next, let's cube both sides of the original equation. Recall that a plus b cubed is a cubed plus b cubed plus 3ab times a plus b. Therefore, t cubed is x cubed plus 1 over x cubed plus 3 times x times 1 over x times x plus 1 over x. Now, x plus 1 over x is just t. Therefore, t cubed minus 3t is x cubed plus 1 over x cubed. So, let's replace these parts with these. So, y equals t cubed minus 3t minus 6 times t squared minus 2 plus 3 times t. So now we have y equals t cubed minus 6t squared plus 12. Next, we need to find the minimum value of t, where t is x plus 1 over x. To find the minimum value, let's differentiate t with respect to x. So dt dx is 1 minus 1 over x squared. And let dt dx be equal to 0, then we have 1 minus 1 over x squared equals 0. So x is plus or minus 1, but the question specified that the x must be positive. So x is plus 1. So when x is 1, t is 1 plus 1 over 1, which is 2. So the minimum value of t is 2. In the second part, we need to find the values of t and x when y is minimum. Let's differentiate y with respect to t. dy dt is 3t squared minus 12t, and let this be equal to 0. So t is 0 or 4. But in the first part, we learned that t must be greater than or equal to 2. So t must be 4. When t is 4, x plus 1 over x is 4. So when t is 4, x is 2 plus or minus root 3. And finally, let's substitute t equals 4 into this equation to find the minimum value of y. So when t is 4 and x is 2 plus or minus root 3, y has the minimum value minus 20. And this is the end of this exam paper. Let me know if you have any questions, and see you next time.